Hi, my name is Alicia, and at AWS, I support customers across different market segments in their AI and ML journey. Thank you so much for having me today. I'm really excited to talk to you about our recent research that I did with Chad and Marcin on recommender systems with LLMs. But also I'll share with you what AWS has to offer in generative AI and agentic AI space. So please stay with us. Okay, so for the agenda, I'll start with introducing the idea based on the advertising and marketing vertical, but I'll show you that it scales beyond that. So if you work in any other vertical, this will be applicable to you as well. I'll do a quick refresher of recommendation systems, and then we'll talk about how LLMs are addressing such problem as well. Um, and after that, I'll show you our model that we introduced and presented at ICB this year for recommendation systems. And at the end, I'll show you our agentic AI and generative AI services that we offer at AWS and that you can start using right away to build your agentic systems. Okay, so let's start with scale. So global advertising is not a small and niche industry anymore. It's already a $1 trillion market. In 2025, global ad spend reached about 1.2 trillion, and it's projected to grow to 1.3 trillion this year and continuing to 1.4 by 2027. And it's not only about the size, it's about the acceleration. This market has doubled in size since the pandemic. And at this point, we are spending roughly $150 per person for every human alive every year on advertising. So that level of scale changes the problem. We moved from traditional economic cycles, and it became a computational system that is powered by platforms, algorithms, generative AI, of course, agentic systems that adapt and change in real time. So let's think about it for a second. Like when market reaches this scale, success no longer comes from louder ads. It comes from systems that can truly understand your audience, the context, intent, and timing, so that the marketing fades into experience. And intelligent system recommendation systems are more important than ever when we think about it. They are foundation of personalization, relevance, and decision making. So this shift to more intelligent systems is what I want to talk to you about today. But before we dive deeper into background of recommendation system and LLM-based solution, I want to pause for a second and acknowledge something important. Recommendation systems are not only about advertising and marketing. They are foundation for many other verticals as well. They power how billions of people discover, decide, and engage with your content every day. So, for example, in e-commerce, they can power product discovery and personalization search. In media and entertainment, they can drive content discovery, content recommendation. In healthcare, that's also a very valid algorithm that can recommend treatment pathways, support decision making. Of course, in automotive, for example, we talk a lot about in-cabin experience, physical AI these days, so they can personalize these experiences, also enable predictive maintenance. Financial services, they power investment decisions, fraud detection, and other use cases. There's also travel hospitality. They can create dynamic travel plans, adapt to your individual preferences. So the core challenge, as we look at that, is the same across all of these verticals. And how you deliver this information to the right person at the right time in a very natural way is what we want to focus on. So before we go into algorithms and solution that we proposed, I want to quickly show you the demo built on AWS. So this demo shows how we use multi-agent collaboration for a content discovery platform. So generative AI combined with machine learning is used for different features in this demo. So you can see that, first of all, we have a chat that we can use to interact with our agentic system. We use multiple agents that can automatically detect filters based on your free-form text to recommend personalized content for you. Agents use multiple tools. These tools can combine traditional machine learning algorithms or LLM-based solutions. We also deliver personalized message and image generation that is generated specifically for this user. So you can see in this quick demonstration the way that you can combine agents along with image and content generation models, and you can start using them right away today. Okay, so now let's look into recommendation system. The base goal of recommendation system is to, of course, suggest relevant items to users. And it has been shown in research that recommendation system can boost click-through rate by even 30% and conversion rates by 5%. So now you can see why it's so important to really think through how you design them and really create intelligent systems, because it can translate to real business values. So how do they often work? One idea is to take into account user profiles. So let's say we have one of our users, and we know the product that this user chose in the past. And then let's say we have another user with demographics or other information similar to our first user. What we can do is we can leverage that information to recommend similar items to this new user. So that's called collaborative filtering. Another approach would be slightly different. So we, again, have our user and we know the history of items that the user selected. And we know other items that might be similar to these items. So we can reuse that information and recommend that item to our user. So that approach is called content filtering. So that will work, of course, but there is one problem. This system assumes that such preferences are static. So let's say we take a point in time, like for example, this point, we assume that it's a good representation of our user preferences. Or, if we take this point in time, we assume that this will be a good recommendation for our users. While in fact the temporal nature of items that users selected, the behavior is very important to represent this user's preferences accurately. So we have to take into account this temporal nature of our behavior. But also the order of selected items matter. Why? Because preferences can change over time. Interactions are sequentially dependent. For example, if we shop for our ski trip, we may purchase some gear and then book the hotel, and then the order will matter. And of course, recommendations are best if they are relevant to our user, not just randomly selected based on generic group of demographics. Okay, so to solve for this problem, sequential recommenders take a sequence of user behavior, capturing this diverse and temporally varying interest over time to make recommendation of the next potential item. So we can see that we will take into account the order and the sequence of user behavior. And various methods have been proposed to solve sequential recommendation. Of course, there are traditional machine learning approaches, deep learning based methods. We all see like how AI is evolving over time. You name it, there are so many methods that have been used for this, including self-attention with transformers or graph-based session recommenders and many others. But there are two main problems that I would like to highlight. So one is the cold start problem. So systems that rely on identity features may result in poor performance in a cold start scenario. Why? Because like when we use embeddings that are learned from interaction history and new users may have no interaction history, embeddings will be either meaningless or just randomly initialized. And then similar new items may lack data needed to learn these meaningful representations. So the system will not be able to leverage any site information effectively if it's dominated just by ID of our items. So that's the first problem, cold start problem. Second problem is when we use limited model capacity. So when we use relatively shallow models, it might be difficult to model complex and diverse user interests. Let's say, we may have a model with 1 or 2 million parameters, but if we have 1 million users with 100,000 items, we'll need many more embedding parameters to represent that correctly. So some ideas were based on LLMs to solve for that. One of the idea of leveraging LLM is to use LLM to provide additional information to recommendation systems, like summary of user behavior, of item information. Another idea is to use chat-like formats for recommendation system, where we would have chat-like experience for recommenders. There's also approach to input ID features directly into LLM and then optimize for our specific objective, like for example, click-through rate. However, LLMs are still not explored that well. And there are some important considerations that researchers are looking into. So one is the complexity of attention and the number of tokens. So let's assume we feed the behavior history or items or any other information as text to our LLMs. We have longer input sequences, so that translates to higher complexity of attention. And then we also may require more tokens for item recommendation, so efficiency can decrease. Another consideration is a question whether the knowledge that is already accumulated in our pre-trained LLMs is sufficient to use it for recommendation system. We know that off-the-shelf LLMs, pre-trained LLMs are really good, and their embedded knowledge is really excessive these days. But the question is whether that could be reused for a recommendation. And then, of course, the scale of LLMs. Does throwing just larger LLM at recommendation problem help? Does more parameters in our LLM translate to higher performance? That's the third consideration. Okay, so one of the really great researches that was proposed to address that is a hierarchical large language model. It was proposed to address such challenges and answer some of these questions. It showed a really great promise. So the approach proposed in this paper began by using LLM to extract item features. To do this, authors appended a special token to the text description of items. And then this augmented description was fed to the item LLM. The output of that was to detect the item feature. And then a sequence of items were fed to the second LLM called user LLM to model user interest, behavior, and then predict a future item that would be relevant. So with that approach, they transformed long item description into concise embedding. So they were able to keep the computational cost really efficient. And what was found in this research was that such approach can outperform ID-based models. So there is a promise of using LLMs for recommendation systems. Also, they show that more parameters translated to better performance. So with scaling to larger models, we can further improve recommendation system accuracy. And also, the knowledge that was embedded in LLMs was indeed beneficial for recommendation tasks. However, the one of the limitations of this research was that they showed that fine-tuning of both models is needed to achieve sufficient performance. And as we all know, fine-tuning is costly. So our idea was to look into this and ask ourselves if there's a way to somehow at least limit the fine-tuning to just a few layers, or maybe just limit the fine-tuning at all. So what we did is we proposed extension of this model that leverages representation alignment to bridge the gap between understanding items and understanding user interactions, and do it in such a way that we would keep the core LLM parameters frozen. So as you can see on the diagram, we introduced a projection layer with cross attention that would act as this bridge between both LLMs and be able to adapt to the recommendation task without costly fine-tuning of both models. And our study showed that it's possible to leverage that approach and keep performance quite high by reducing the training time by 30%. So that was a big saving, both in time and cost of the fine-tuning. Another finding was that the frozen item representation was sufficient for recommendation systems. So in our study, we managed to keep the item LLM completely frozen and just feed it to the projection layer and then the user LLM and still achieve good accuracy. What that gives us, it's another finding, because now we have a possibility of using other language models, including multimodal vision models, and reused embeddings from these models to boost accuracy further. And we had a small experiment in our research that used a multimodal model and showed that indeed accuracy could be improved. Another important finding is that there is asymmetry in how LLMs should be adapted for recommendation tasks. So we found that items are shared across multiple users. We can just reuse item representation without training, while user representations are unique. So a small fine-tuning of user LLM, just two top layers, resulted in the best performance. So that was the model that we proposed. What's important in my view is that with such approaches, we can move from recommendation systems that require extensive training for each domain to LLM-based approaches that can reason about content more dynamically. And this flexibility is really important for agentic systems that can operate across multiple domains and contexts without specific domain fine-tuning of each item LLM. Okay, and speaking about agentic system, I want to highlight that at AWS we have solutions to make it very easy for you to build agentic systems, as you saw with the short demo that I showed initially. Last year we introduced Agent Core, which is a managed system for building agentic workflows. And what's important it is that it has various components that can handle the entire life cycle of agentic pipeline, from runtime, memory, identity, observability, gateway, and many others, to address all the parts of the agentic pipeline. And beyond that, we also have other services that you can leverage in combination with Agent Core. Bedrock is our generative AI service with multiple models, and I believe like the broad selection of models is crucial these days, because there's no single model that will work for all use cases. So having this flexibility and being able to easily switch between models is what matters. We have our personalized service as well. That is our recommendation engine service. There's also SageMaker, which is more generic AI machine learning service with a lot of functionalities from ML lifecycle, ground truth for labeling, and many other features that are crucial for building machine learning systems. And we also have our family of Nova models that you can leverage. These are understanding models and generation models, along with many customization options like Nova Forge or distillation. So just to wrap up, we are looking forward to working with you, transform your business together, experiment on the latest generative AI technology and advanced research in recommendation systems and also other domains together. So please contact us and yeah, let's work together.